Hey guys, so in this video I'm going to go ahead and give some geometric intuition using Desmos to the result that we just found. So what I've done is I've taken all the y1, y2 combinations that are in our set y and I've plotted them here. We have 0, 0, negative 1, 2, and negative 3, 3. We can produce 0 outputs with 0 inputs, 2 outputs with 1 input, or 3 outputs with 3 inputs. Those are the 3 vectors in our set y, and I've plotted them as points here. So now what we're going to do is we're going to add on the line with slope P2 over P1. And there we go, got a nice label on it. So what this line is it shows the line with slope P2 over P1. Right now I have P2 over P1 to be 1. If I increase P2 to be 3, but I keep P1 at 1, we see that that gets steeper. And I can play with the values of P1 and P2 to get various shapes of this line, to get various slopes. So now what I'm going to do is I'm going to add on the isoprofit line. What this one represents is it's all the different y1 and y2 combinations that give me a profit of 0. So if I get rid of these points quickly, what we have is 2 perpendicular lines. And no matter where I move this line, and no matter what I do to play with these P1 and P2, you'll see that these are always going to be perpendicular. And that should make sense because algebraically, P2 over P1 is the negative inverse of negative P1 over P2. And those are those 2 slopes. So if you have those 2 slopes, they're perpendicular if they're negative inverses of each other. If that part doesn't make sense, it's just you have negative P1 over P2. If you take 1 divided by that and you multiply it by negative 1, you get this slope. And that's what ends up being true for two lines to be perpendicular. So now what we can do is we can see what happens as we vary kappa, but keep P2 and P1 the same. Here we see that as we increase kappa, the amount of profit, the curve just shifts. It shifts higher along this green line. It shifts out from the origin. And it's always perpendicular to that green line. And so now if we add back our feasible points, not sure why the keyboard popped up there. If we add back our feasible points, we can see that what we really want here is to get as large possible of a kappa subject to being on one of these points. So what that amounts to here is lining up this red line as far out along the green line as possible, hitting one of these points. And it's proving to be somewhat annoying to get the slider to line up correctly. There we go. So what we've done now is we've pushed it out as far as possible while still being on the feasible points. For example, if I were to shift P2 and P1 like this, not sure why the keyboard's popping up again. If I shifted them, say, like this, we now start again at 0 profit, and we shift out as far as possible subject to having to hit one of those blue dots. So here we have kappa set equal to 4, and what that tells us is that we're making profit 4, and we're pushed out as far as we can get from the origin, because any further and we don't hit any of the dots, we can go less and hit negative 3, 3, or go all the way to 0 and hit 0, 0, but the most profit we can get occurs when we're at negative 1, 2. And that's kind of the geometric intuition behind it.